Yes.
Yes, sir.
Okay. So 1 by 20, not 20, here it is different, but I am telling one example. So 1 by 20 millisecond. Okay. Means what will be thus in second? That is cycles per second is your hertz. Okay. So convert it to hertz, kilohertz, megahertz, gigahertz. Okay. You know what is megahertz?
Yes, sir. 10 to the power 6.
6. Kilo means 10 to the power 3.
Yes, sir.
Yes, sir.
Mega 10 to the power
Yes,
6.
Yes, sir.
Giga 10 to the power 9.
Yes, sir.
Okay.
9. Yes,
So,
sir.
so
Yes,
this is the procedure for calculation of the peak to peak amplitude. At the same time, from the time period, we are getting the frequency of the signal. Okay. Now, Jagannath, start.
Yes, sir. Now say our frequency changes. So from where it will change? CRO will change nothing because CRO is a measuring instrument. So who can change the frequency? Who have actually generated that frequency. That is a functional generator. So we are now increasing our frequency. You just follow. You can follow both the screen also. And now the frequency is more or less 1 kilohertz or whatever is there. How to measure? You can measure from here to here. Or say if it is very close or it is very difficult to measure from here. So what to do? For high frequency, you will select a higher time per division scale. Now you can measure it is from here to here. 1, 2, 3, 4, 5, 6 division and it is 0.1 millisecond. So if your frequency is low, you have to go a lower scale. If your frequency is very high, you have to go a higher scale. So any frequency or any amplitude you can measure from CRO. Now, I want to say you something about the knobs of the CRO.
Stop it. Students, do you know what is the value of frequency for DC signal?
Yes, sir. 0.
0.
Yes.
So what is the time period?
Yes, sir.
Infinite.
So I have a very simple question now. You have studied already rectifier in the basic electronics class?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
What is basically an AC? AC signal means its value will periodically change and it will have both the polarities. Yes or no? Positive, negative.
Yes, sir. Yes, sir.
Okay?
Yes, sir.
Okay.
Yes, sir.
Okay. What do you mean by DC signal? It will have a single polarity, either positive or negative, and its value is almost constant with respect to time. Yes or no?
So value may not be constant.
No. But okay, I agree. But perfect DC means its value is constant. Okay? Okay.
Okay, sir.
Yes,
But
sir.
the main
Yes, sir.
conception is it has a single polarity. Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Across half wave or full wave rectifier, you are getting one positive half cycle being rectified, then one straight line, no rectification, then straight line like this. Across full wave, you are getting all half cycles. Okay? So this output of a rectifier, is it DC or AC?
Sir, DC, sir. Pulsating DC.
DC.
No, give me the answer specifically. Is it AC or DC?
AC. AC.
Huh?
AC.
AC.
AC. I
DC.
want to know the nature of output across a rectifier. Is it AC or DC?
DC.
DC.
There is DC.
If I see the output,
DC. Or DC.
you see my statements are correct or wrong. That the output of a rectifier that you are getting, it is AC in the sense that its magnitude always fluctuates. Yes? Yes or no?
Yes.
Yes, sir.
But it is not AC in the sense that it has a single polarity. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
It is DC in the sense that it has a single polarity. Okay?
Yes, sir.
Okay,
It is
sir.
not DC in the sense that its value is changing. May I conclude these four things? Yes or no?
Yes, sir.
Yes, sir.
Yes. So can I say it is DC? It is not DC. It is AC? It is not AC. Yes or no?
Yes, sir.
So what is this? That's why it is called pulsating DC. Okay? Why pulsating DC? Because DC in the sense that its magnitude changes, pulsating, and DC means it has a single polarity. Okay? Now, to get complete DC that I was telling just before few minutes back, what we do? We connect this pulsating DC to one filter circuit. Okay? Filter circuit. Have you studied filter circuit?
Yes, sir.
Yes, sir.
Yes, sir.
So to get more DC, that is perfect DC. Yes. So now I have some questions, students. Now if you can answer, you will see that maximum things are very much clear to you. What is the input of a rectifier? Tell me, answer. What is the input of a rectifier? Huh?
AC.
240.
AC.
AC. What is the output of a rectifier?
DC.
Neither perfectly AC nor DC.
Pulsating DC.
Pulsating DC.
AC plus DC.
It's pulsating
What
DC.
is the input for a filter circuit?
Pulsating DC.
DC. What is the output of a filter circuit?
Nearly ideal DC. Nearly ideal DC.
DC. With minimum ripple.
AC.
Okay. Ripple, you know?
Yes, sir.
Ripple factor.
Yes, sir. Wave.
Pulsating DC.
Yes, sir.
Okay.
Yes, sir.
So, okay. What
Sir,
I told you
sir, I have a question, sir. Sir,
starting the class that I shall complete the last 3 modules during my schedule time, and after that thoroughly I shall go through all the portions like this. Okay, very quickly. That what is the input, what is this, so that ultimately you will be a masterman on this subject. So now I want to ask you. So depending on the nature of the filter circuit, your output will be that type of DC. What is the best filter? Have you heard it? What is the best filter?
no, sir.
One filter is there, capacitor filter, then choke input filter, and the combination of 1 and 2 is called capacitor input filter. Okay, that is the 2 capacitors parallelly, in between one choke, means one inductor, and it is looking like pi, so it is called also pi filter. Okay, on the upper stand we have one inductor, then 2 vertical bars, we have 2 C's, means it is looking like mathematical pi 22/7. Okay, are you getting my point, students?
Yes, sir. Sir, it can be also be called as T topology.
No, but
T or
it is
pi.
called pi filter, the universal name.
Yes, sir.
We cannot give the name, okay, students. And how it will be
Yes.
T? 2 bars are there, 2 bars. Okay.
Sir,
You got
I am
the answer?
considering one bus, sir.
No. If it is 1 bar, it is T. But 2 bars are there. 2 bars, 2 C's. Okay. Okay.
Okay,
Students?
Yes, sir. Yes, sir. That C is in the
Yes,
in
sir.
parallel. No, sir. C is in
2
parallel
C's
of the
are
circuit
parallel.
of the road. Yes, sir. Thank you, sir.
So are you getting something, students? New thing?
Yes, sir.
Yes,
Yes,
sir.
sir.
Huh?
Yes, sir.
Yes, sir.
Okay. So are you enjoying the class?
Yes, sir.
Yes, sir.
Sir, what is
Okay.
this here?
Okay, Jagannath, start.
Yes, sir.
You just follow. Signal is connected in channel 1. Now here it is written XY. XY means if we press this one, a vertical line, that is maximum to minimum amplitude we can measure from here. XY. Here it is written channel 1/2. When it is open, then it is showing channel 1. If it is pressed, then it is showing channel 2. Nothing is connected. If we connect in channel 2, then we can obtain our signal again. So So that is the signal in channel 2. And when it is connected in channel 2, we have to vary this volt per division, and we will follow this reading, this green color. And when it was in channel 1, then we will vary this blue one and we will get the blue reading. Clear? Now the next part, it is a Lissajous figure. So what is Lissajous figure? When two separate signals are produced in X and Y, that means channel 1 and channel 2 of a CRO, then by superimposing of these two signal, we can obtain some figures in the screen. That is called Lissajous figure. So better we will get a Lissajous figure first. For this, you have to press X, Y. You just see what is this? It is a circle. Actually, some Lissajous figures are here. You just follow the first line, it is a circle or an ellipse. Second line, it is more or less figure of 8. Then another figure. So these are the Lissajous figure. So from here, from Lissajous figure, we have to calculate an unknown frequency with reference to a known signal and a Lissajous figure. So for this, a formula is there. That is FV into TV equal to FH into TA.
See this formula.
So what is FV, TV? This is our Lissajous figure, an ellipse. So it is x-axis, it is y-axis. So whatever frequency is connected in x-axis, that is called Fx. Whatever frequency connected in y-axis, that is called Fy or Fv, vertical frequency. And what is THTV? Nothing. In a Lissajous figure, we can draw tangents horizontally and vertically. So number of point touched in Lissajous figure, tangent touched in Lissajous figure, that is called TH. That is 1, only 1.
Hello, sir.
Jagannath,
Internet so poor.
any problem?
Internet connection so poor.
Oh,
Sir, what is case, sir?
hello,
Yes, sir.
Yes, sir.
Jagannath,
Yes, sir.
what is the problem? Net connection?
Yes, sir. Internet connection.
Okay. So, but your sound is audible highly.
No, sir.
So, is there any video problem?
No, sir.
Huh?
Try again.
It was running nicely.
Internet connection is poor.
As a students, you have got it, na? This experiment?
Yes, sir.
Huh?
Yes, sir.
So you see that.
Sir, what is case?
Yes, sir.
Huh?
Sir, what is K, sir?
Where is K?
Yes, sir. What is K? K equal to 1, K equal to 2 in the Lissajous figure?
Oh, you see that this is the Lissajous figure. So it touches the horizontal line at a single point. Okay? Yes or no?
Yes, sir.
And
Yes,
here
yes,
it is
sir.
2 points. Okay? 1, 2. So this is 1, this is 2. Okay? Are you getting?
Yes, sir.
Yes, sir.
Jagannath?
Yes, sir. Yes, sir.
Acha, you start again the recording and come to this point quickly. Then you see that I think it will be okay.
Okay, sir.
You again start the recording and come to this point. 8.37 times. Time.
Okay, okay.
Okay?
Okay, sir.
Uh-huh. Again you give it. জগন্নাথ
Yes, sir. I am here.
কি
Internet connection is too poor.
হ্যাঁ
Internet connection problem.
ইন্টারনেট অফ হলে তোমার কথা শুনছি কি করে?
Sir, ভিডিওটা আসছে না তো।
ও মানে ব্যান্ডউইথের প্রবলেম?
Yes, sir.
হ্যাঁ
Yes, sir.
আরেকবার স্টার্ট করো না, দেখো।
করছি।
Students, can anyone you run the video? It is with you, Somik. Somik,
Yes, sir.
can you run the video?
Sir, I have a network issue, sir.
You have also network issue.
Yes, sir. That's why I wasn't able to join earlier.
Oh, any student?
Shumit? Yeah, that day you were showing, no? Shumit?
Yes, I am trying. I am trying.
Okay.
Yes, sir, I can also.
Anyone, you try.
Yes.
From
Okay, if you try,
8.37 times.
he will show.
Sumit, are you doing? Sir, is it visible?
Okay.
Yes, sir.
Now
Hello
start.
student. Today we are going to
8.37 you go.
perform
8.37.
on CRO. That is cathode. Then
8.37.
another figure. So these are the
next.
x-axis
Next.
tangents. Horizontally and vertically.
Now students,
The
you
number
see.
of point touched in Lysager's figure, number of point touch, this tangent touch in Lysager's figure, that is called TH. That is how much? That is 1, only 1. Here also, number of point touch in vertical tangents, that is also 1. So here formula is FV into TV equal to FH. Just follow. This is the Lysager's figure. This is tangents parallel to x-axis, and that is tangent parallel to y-axis. So Fx is the horizontal frequency. Horizontal frequency actually you just follow. Channel 1 is written y, channel 2 is written x. That means whatever frequency is given in channel 1, that is actually the vertical frequency. This one, this one, vertical frequency is entering here. And channel 2 is written x, that is the horizontal frequency. That is actually our this instrument. So this frequency is fx, this frequency is fh. Now any one of these two may be a reference frequency, another should be unknown frequency. So say our reference frequency is fh, that is this one. This one is reference frequency. We know that the frequency here. So what is this? It is 1 kilohertz. So fh equal to 1 kilohertz. Then clearly FV and TV both are 1. Sorry, TV and TH both are 1. Then what about FV? FV equal to FH into 1 by 1. That is, it is also 1 kilohertz. So the FH, whichever was unknown up to this point, now it is known. It just follow. The both are 1 kilohertz. Okay. And when both frequencies will be equal, then only a circle or an ellipse may appear, because here 1 point, here also 1 point has cut. Okay. Now we want to go, change our frequency. That means this is our reference frequency and we will change that frequency. So say we can make, and if you follow the Lysager's figure, we are changing our frequency. How much? Say it is only 500 hertz. Now just 500 hertz. You follow horizontally how many points got touched? 1, 2. Vertically, how many points? It is 1. So it is 2:1 figure. And you follow both the frequencies. One is 1 kilohertz, another is 500 hertz. Clear? Now we are changing again our frequency. Now we are try to set it to 2 kilohertz. Now just follow. Here it is 2 kilohertz, here it is 1. So now this frequency is double. That frequency is double. So you just follow. Now horizontally only 1 point touch and vertically 2 points. So it is frequency 1:2. That means this is 1 kilohertz and here it is 2 kilohertz. So any frequency can be measured. Some more research figure I want to show you. 3. So it is 3:1 figure. Just follow. Here it is 3 kilohertz and here it is 1 kilohertz. And the figure also saying that horizontally 1 point touch and vertically is 1, 2, and 3. So it is 3 times frequencies. So using CRO, what we can do? We can measure amplitude of an unknown signal. We can measure the frequency of unknown signal, and by using Lysager's figure, we can compare 2 frequencies. One is reference, another unknown. So that's all.
Students, Jagannath.
Yes, sir. I'm here.
Today, you send them again in the group mail experiment number 3 recording. Okay? Because
Okay.
if for next Tuesday, if there is from your end any networking problem, this student or any student can run the video. Okay?
Okay.
So, and Somik,
Yes, sir.
so Jagannath sir is sending it to your mail, you send it to group mail. Okay,
Okay, sir.
okay. Or
Sir.
group mail, whatever the case is. Achha, one student has asked to how to write the report. I have already mentioned that you go through the video recording of experiment number 1 and 2. Suppose any experiment, then what you are observing from the experiment, you just write in the report what you are observing. Okay, so today I have clarified more or less something regarding your experiment number 2, experiment number 1, how to measure the value of resistance of a resistor. This is given simply in video recording of experiment number 1. So experiment number 3 today will be sent to your mail. You see again next Tuesday I shall run experiment number 3 with the help of Jagannath or my students of this section I. Then again I shall clarify all the points. That's all for today. So I am leaving
You have to
today.
write only the observation, right?
Just write it simply. But again, I want to repeat that you have to write your name, roll number. You will write that report on experiment number 1 or report on experiment number 2.
Sir, it is
And-
report report.
Just observation with some
Sir,
accordingly your input data. If there is any input data, you are writing. Now,
Sir, what is
excuse
the
me, sir.
last date?
last date means,
Last date.
no, you see that within this week you send it to Somik's mail. Okay, what I told you.
Sir, Sir, can we
Individually
get a
you-
sample?
Huh?
Sample of written report as such reports? Any sample? So that we can see the first experiment and write.
You see, students, you write as you like. That is, there is no standard way in the online mode. Offline mode, I can give you some documents and everything so that you can see how to write. But in the online mode, just you write your observation on that experiment at your own language. Okay, use your own language, no problem. You have to just submit it will not carry any marks for that. Okay? Are you getting?
Yes,
Okay, sir.
Yes, sir.
But
Okay, sir.
submission is essential. Okay? So, you write and you submit it individually to Somik's mail. Okay? Somik Vishwas, your CR. Somik will compile all
Okay,
this
sir.
as per serially your roll numbers and then we'll send it to us. Okay? Okay?
Okay, sir.
Okay, sir.
And today, বলছি, today we will send it to that is experiment video recording of experiment number 3. Then you run it individually. Again, next Tuesday I shall run, and with interruption I shall tell stop, and the clarification I shall give. That I have given you today. Now, any question?
So we can submit within next Tuesday.
Tuesday. Okay.
Okay, sir.
Okay. So today
Okay,
I
sir.
am leaving.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you all.
sir. Thank you, sir.
স্যার বেরিয়ে গেছে মনে হয়।